just be mindful of the fact that any question is fine, any unwanted question is not. When you put unwanted question, if it takes 2 minutes, we are wasting 20 minutes of everybody's time. We will not do that. So be careful with what we ask versus what we should not be asking. Alright. I'm just checking who is missing here. Who is missing here? Gitesh we have. Pranav, okay. Okay, Pranav is there. Kaushika is there. Dikshita is there. Sarmika is there. Oh, Sanvi is missing. That's what I was wondering. You would not know. She is joining from New Jersey. Okay, Sanvi is the only one who is missing here right now. Sanvi, are you there? Okay. Okay, alright. So I think we have everybody except Sanvi. I'm sure she would join. Let's get started. What did we learn yesterday? No, it's a very simple question. We learned area of, how to find out the area of rhombus. Huh? So, okay, that is what we understood as a concept. Okay, so again, don't trigger a debate. Okay, don't do that. Now, so we found out how to derive the area of a rhombus, and then after doing all that we did, we found that area of rhombus is two diagonal multiplication of diagonals divided by 2. So if I have two diagonals, if this is my rhombus, this is my one diagonal, this is my second diagonal, the area of the rhombus is d1 into d2, meaning diagonal 1 into diagonal 2 divided by 2. This is my area. And it did different sums where we knew the perimeter of the diagonal and we knew one of the perimeter of the rhombus and one of the diagonal, and then we solved it. We knew side of the rhombus, one of the diagonals, we applied Pythagorean theorem to find out the second diagonal, and then we solved it. So these are some of the problems that we solved yesterday. Now today we are going to deal with another shape called kite. So kite, there is nothing here about it, it's just a shape. Okay, so first thing first is we need to remember or recall how a kite looks like. I'm not asking a question, I'm teaching. What is it? No, I'm not asking again. That's one thing. Just be mindful of the fact that every unwanted question or any unwanted discussion is going to waste 2 minutes of everybody's time. So let's be careful about it. Okay? And that doesn't help you or me either. Right? So let's be careful about it. Now, when I'm talking about a kite, if we recall the property of a kite, again I'm not asking question. Kite is a shape which has the sides in pair which are equal. So these two sides are equal to each other, these two sides are equal to each other. Okay? And then the line that joins the two opposite vertex, that divides that in a symmetric way, meaning it divides it equally. So this part of the kite or this area of the kite will be same as this area. That's the only property we need to know. I'm sorry? You can see, you move to the side. So when we look at a kite, the only property that we know about is it's a quadrilateral, obviously. It has 4 sides. These two pairs, so this one pair of sides are equal to each other. This pair of sides are equal to each other. Okay? And then these two vertex, if you join them, this becomes one of the diagonal. This divides this kite into 2 equal parts. That's the only thing that we know as a property. So far, any questions? No? thing is this. Other property that I have not told you guys before, but I'm just telling you guys in this class now, that same as rhombus, the diagonals no, not with the kite. Sorry, my bad.
They are all like equal, but it's just like a different size.
Yeah, so then there's nothing that you can relate. So the middle diagonal splits that into two equal area. Okay? Hold your horses. Now, if you have to find out the area of this kite, how will you find it? How? Yes, huh? Okay. So, coming back to this one, okay? Maya, you're saying something?
Were you asking the formula for the area?
Area of a kite. Would you know it by any chance? At least I don't.
I would normally make an assumption that it would be somewhat similar to the rhombus.
No, don't assume. That's not correct, okay? So here, let's say, let's try recalling the properties one more time. So if I have a kite, this diagonal splits that into two equal parts, and this diagonal, they just make 90 degrees with each other. So that's the only thing that you can relate. Okay, that's the only property. Now you have one triangle, second triangle, third triangle, fourth triangle. These four are right angle triangles. And to find out the area of this kite, you have to find out the area of these four triangles and add them together. That will be your way to find out the area of a kite. Let's do it. So let's say this is A, this is also A. If this is B, this is also B because they are same. And let's say this is B. Here to here is B. Or let me give it a name. A, B, C, D. I will say this is L1. This is also L1, length 1. This is length 2. This is also length 2. Okay. Now, these two are meeting at this point. So in this case also, again I don't know whether finding out the area for this one will give us an easier solution for this, or you will ever have to find out the area for kite, but let's try finding it out. Let's say these two are meeting at O. So these are all making 90 degrees. So there are four right angle triangles. So this triangle and this triangle will be congruent. Again, these two are right angle triangles, these two sides are matching, this side is common. They don't. So now every angle is the same. Because they are congruent now. So this angle will be the same as this one, this angle will be the same as this one. But, so I am saying let's not worry about the angles at all. I am saying this is a right angle triangle, my hypotenuse are matching and this side is common. Done. I'll close it there. So these two triangles are congruent. Same way this triangle and this triangle are also congruent because the hypotenuse are matching and this is common. So now by area of kite will be equal to 2 times area of this triangle AOB. Okay, and 2 times this triangle area of BOC. So again, maybe I went a little fast. Before one, I think you missed few classes in between. You missed few classes, so you might not be remembering the or not knowing the theorem of congruence that we have learned. So I had requested you to go through some of the videos of the previous classes. I'm hoping that you did that. Okay. So then I don't have to repeat. So now what I'm saying is, we are trying to find out the area of this kite. Okay. And unfortunately I don't know what is the formula. So we are trying to derive it. Yesterday also we were trying to derive the area of area of rhombus, and the same way we derived it. So this is my kite. What we know is this side are same, this side and this side are same. That's my property of my kite. And also I know that the diagonals of the kite cut each other at 90 degree, and the vertical diagonal splits this into two equal parts. You had a question. So A or B, see again, when you ask a question, I would say just think about it. Because in the examination hall, I will not be there. When you are writing STAR test, or when you guys grow up and give SAT test, I will not be there in the examination hall. That is where you have to think. Now A or B, this is meeting at O, that's what I am saying, right? When you say A O B, what is this A O B? It's nothing but the triangle. This right angle triangle. So this right angle triangle and this right angle triangle are congruent because my hypotenuse are matching, this side is common. So this area and this area are same. Similarly, this triangle and this triangle are also congruent. So this area and this area are the same. So basically what I am saying is, if I find out this area, meaning this triangle and this triangle's area, and multiply that by 2, I will get the area of a kite. So now, this area, AOB, okay, 2 times area of AOB. What is this? This is a right angle triangle. What is the area of the right angle triangle? Is area of this triangle, I will put it inside. Half into base into height. What is my base? Let's say this I am calling as a base, AO, into height. That is BO. So far you guys are with me, or am I creating confusion? So far with me? Okay. Yeah. So area of a right angle triangle is half times base times height. So half times base, if I am considering this as base, and then height, plus this second triangle, this one. What is the area of this triangle? This is also a right angle triangle, 2 times the area of this guy. That is half into base. Let's say this is my base. So it is OC into height. Height is what? BO. Yeah. Now look at this. 2 into half. I can do tic-tac-toe. Now this becomes AO into BO plus OC into BO. Now BO is common. This BO is common. So I'll say BO is common. And then AO plus OC. AO plus OC. Now, if you look at AO plus OC, AO plus OC is nothing but my diagonal. BO into this diagonal, AC. Or I will call this as my diagonal 1. BO into diagonal. Now this BO is what? This is half of the second diagonal. So, I am saying BO as my second diagonal divided by 2 into my first diagonal. So this also turned out to be D1 into D2 divided by 2. So what Myra was saying, that turned out to be right. In the case of a kite also, my area is D1 into D2 by 2. So now you guys have a common formula for area of rhombus and area of kite. Area of a rhombus and area of kite have same formula, D1 into D2 by 2, wherein D1 is your first diagonal, meaning one of the diagonals, D2 is the second diagonal. Making sense or making nonsense? Sense? Okay. Yep. So I have to ask Amuga, Sagnika and Cherry. You guys raised your hand. I don't know who raised the hand and what the question was. Okay?
So yesterday I saw a video, I was searching up, I saw a video to, make more understanding.
Uh-huh.
And it said that if it gives different measurements in the rhombus, there's, different formula.
If you give different measurements in the rhombus, it gives a different formula. What do you mean by that?
If it gives another, in another part of the rhombus, so if it gives P and Q or something, it's like PQ.
Yeah. So you can see, you can give it a name. So one thing that we derive, okay, again, you don't have to trust me. I'm not talking about it. We just did it together, right? So if I made a mistake, you all made a mistake. We all partner in crime. We proved that together, okay? So we saw that the area of a rhombus came out to be diagonal 1 into diagonal 2 divided by 2. Same thing happened this time also. When we were trying to solve or find out the area of a kite also. Same thing happened. So now, whether you call it d1 into d2 by 2 or you call it p into q by q, up to you. But the summary is, it's one diagonal multiplied by second diagonal divided by 2. The relief that you have is, see, I get worried when I have to force you guys to memorize formulas. Because if I force you to memorize, I'm actually forcing you to forget also. Whatever you memorize today, you will forget tomorrow. It's very likely. Except the tables. Because that's why I'm asking you guys to memorize tables again and again. Yeah? So net, if you memorize the formula, you will forget. If you figure out how to solve it, it will last with you much, much longer. Now, trust me, I had not looked at this formula for the last 35 years. Or maybe 30 years. I had looked at it when I was in 10th grade. That's a very old story. Almost 30 years ago. But I could recall my basic understanding of geometry and applied it here. And I was able to derive it. Even when I grow old, when I have only grey hairs, then also I'll be able to derive it because the concept is not going to change. I did not memorize anything. And whatever I had memorized, I forgot. Same thing applies for you guys. Whatever you learn as a concept, when you derive it and you come to a point that, yes, this is what it is, that lasts with you much longer than your friends even. Your friends might leave you, go to another college, but the concepts will remain with you, regardless of which college you go to. Okay? Alright. So we learned about the area of rhombus. We learned how to find out the area of parallelogram in the previous classes. We learned about how to find out the area of rectangle and square also in the previous classes. We learned about how to find out the area of a triangle as well. Area of a right angle triangle actually in the previous class. We learned about the theorem of congruence. We have not learned about how to find out the area of a trapezium. Area of a trapezium. Do you know what is the area of trapezium? Trapezium or trapezoid is a shape like. What is that?
Baseline height.
No.
B1.
That is where if you.
It's not baseline height. You have to take out like the edges to make right triangle into make a rectangle.
No.
No, it is.
No, if I'm saying no, there's a reason to it.
You have to draw a line with like.
No, you have to draw a line. That part I understand. What I'm saying is, there is a formula that I have told you guys, and I'm proving that point again. That if I made you memorize it, you would end up forgetting. That's what I'm saying. Yeah.
So you have to cut to make it to right angle triangle, and then you have to look at base. So we.
Okay. Hold it there. Now, when we are looking at a trapezoid or trapezium, it's again a quadrilateral. It's again a quadrilateral, meaning it has four sides. And the only property that we need to remember about this shape is only these one pair of lines are parallel to each other. Just parallel, nothing more. There is no comparison between them. So if I am saying parallel, probably I will put it like this. So that way it doesn't create confusion. Okay? I am saying only one pair of lines are parallel to each other. I did not say that they are equal. Okay? So don't even worry about that. Now, area of a trapezoid. Somebody is raising hand. Who is that? Okay. Amoga.
Is the formula A plus B times height divided by 2?
Yep. Area of trapezoid or trapezium is half into sum of parallel lines multiplied by the perpendicular distance between them. This is what you would have remembered. Okay? I think we looked at this formula before and you forgot. It's very natural because we just looked at the formula. Now you will ask me, are we going to prove it now? Answer is no. The reason being, if I try proving this here in this class, I'm just thinking.
I think I wanted to know, but then I got it.
I'm just thinking. Allow me to think. I'm just thinking. Can I prove it here? I think we can prove it here. We can find out the area. I was thinking that this might need some understanding of calculus, but without calculus also I think we can prove it. How much time do we have? We have enough time. So this is my trapezoid. And probably I'll agree to what Adrik was saying. He was saying that break into two right angle triangles and the rectangle and then which is the equation. Now there is no fight here. Okay? Nobody, I'm not trying to prove anybody right or wrong. This is my trapezoid. A, B, C, D. Okay. Now my hands are tired. Not ready to work. A, B, C and D. This is my trapezoid. We are trying to find out the area of the trapezoid or the formula that we talked about, half into A plus B multiplied by H. What is H? H is the perpendicular distance between the two parallel lines, okay? So here to here is H. Here to here is H. Okay? Now, this is A, meaning and this is B. This is the second parallel line from here to here. And this is A. Okay? Everybody with me so far? Okay. Now this is my trapezoid. I am trying to find out if whatever Amoga said was right or not. Okay? We will either prove Amoga right, we'll vote for her, or we will say, okay, this is not the right formula. Okay, alright, let's move on. So here, let's say, what I'm doing is, I'm drawing a perpendicular line from this point, this vertex, onto this place. Let's say this cuts at P. And I'm drawing another perpendicular line from here to here, which cuts at Q, meaning this is 90 degree, this is 90 degree, this is 90 degree, this is 90 degree. Okay? Now, this trapezoid converted into three shapes. One right angle triangle here, second right angle triangle here, and this rectangle here. Meaning, here to here it is A. This is A actually. Because we have drawn a perpendicular line, right? Now this became a rectangle. So this is a rectangle, and then you have two right angle triangles. So if I find out the area of this rectangle, and then the area of these two right angle triangles, that together will give me the area of my trapezium or trapezoid. So I'm saying total area will be equal to area of, let's say, ACP, AC and P, this triangle, plus area of this rectangle, which is ABPQ, plus area of this right angle triangle, which is BQD. So far it's okay, right? I'm saying this area of trapezoid or trapezium is sum of this area plus this area plus this area. This is my right angle triangle, this is my rectangle, this is my right angle triangle. So far everybody with me? Yes, Siddharth?
Sir, I don't understand about the formula.
So you don't have to understand this formula, okay? Ignore this one. This is what we are trying to find out, okay? This is...
No, like the one under the trapezoid.
Oh, this one?
Yeah.
Okay. So, what I'm doing is, I'm writing this in a simpler way, okay? It's like the English part of it. I'm saying this is my trapezoid. What I'm doing is, I'm breaking this into three pieces. What did I do? I have drawn a perpendicular from here onto this line, which is cutting at P. I'm drawing another perpendicular from this point to this line, which is cutting at Q. So, this is one right angle triangle, ACP. So I'm saying my total area of this trapezoid is this area plus this area plus this area. That is what I have written here. Okay? So this area is area of this triangle. This triangle's name will be AC and P. Area of ACP. I have just written the English part. Okay, there is no formula here. Okay. Yeah. So AR is the acronym for area. That's what I've used. Area of this triangle, then area of this APQD, and then this area. This is this one. Is this clear, brother? Yeah. Okay. Now, area of this triangle will be what? This is a right angle triangle, which will be half into base. Let's say base is CP. Get the base into height. This is my height. So I'll write H. This is one area done. Plus this area is what? Base. This is a rectangle. The area of rectangle is what? Length times width. What is my length? A. Here to here. A multiplied by height. Plus area of this triangle. What is the area? Here. This is a right angle triangle. So it will be half into base. That is what? QD. Here to here. Into height. Okay? So now, this is CP and this is A. A is what? I will write A as PQ. Okay? So that I can take the common things out. So here, what it became was, I have H I can take out here from this one. So this becomes half into CP plus PQ into H. H I have taken out, so this becomes PQ plus H I have taken out, this becomes half into QD. Here I don't have a half, that's why I'm holding it for now. So my area became H outside and then something into something. Now look at this. Let me take this line out so that I can continue with my calculation. So this is H out, H is out, then I have a half into CP, this is this length, plus PQ plus half into QD. QD is this length. Okay. Are you guys with me so far or getting confused? Everybody with me so far? Okay. Now, let's do one thing. I will not write PQ. I will write 2 into half into PQ. Will that be okay? Because I can do tic-tac-toe. This is PQ only. Yeah. So now I can take half also out. Half into H. I am taking out. What do I have now here? Half is taken out. I have CP plus 2 into PQ plus QD. Now look at this. CP plus 2PQ plus QD. This is CP plus QD plus PQ. So what I will do here is half into H I am taking out. Now I am taking out the last line, okay, to create some space. I have, my equation has become half into H CP plus 2PQ. I will break it into two parts. PQ plus PQ plus QD. Okay. Now take this. What I will do is I will move this PQ to the I just jumble them, okay? I just move them around. That's all. Why? Because CP plus PQ plus QD. This is my second side. CP plus PQ plus QD is one side. And this PQ is what? PQ. PQ is same as this one, A. So it became half into H multiplied by CP plus PQ plus QD. CP plus PQ plus QD. That is nothing but my base. That's one of the parallel line. This PQ is nothing but this line. That is A. What did it become? Half into height into sum of the two parallel lines. So it might look confusing, okay? It might look, no, it's not that confusing. It's easy. Okay. Then I'm the only guy who has lower IQ probably. You guys are much more intelligent than me. That's good. So here, what I was trying to say was, what did we do? We did not do anything fancy, okay? Just because we had learned what is the area of right angle triangle, half into base into height. We knew what is the area of a rectangle, that is base into length into width. What we did, we had a trapezoid or trapezium. We just broke it into 3 components. That is what you will do with when you deal with composite shapes. You have a complex shape, you break it into smaller pieces and you find out the area of different pieces and add them together. That becomes the area of a composite shape. There is no formula that you will come across for a shape like this. Let's say somebody says find out the area of this shape. There is no formula just for this guy. Yeah? Yeah, Vivan.
Sir, are the triangles always formulas?
No, they are not. Because if you look at the definition of a trapezium, it doesn't tell you anything. It just tells you that trapezium is a quadrilateral where one pair of lines are parallel to each other. That's it. There is no extra information that you have. So, what I mean by that is, if you are looking at a trapezium, your trapezium can really go nasty, okay? Yeah, you can have a trapezium like this. You can have a trapezium like this. Yeah? So, here, this triangle and this triangle by no means can be congruent. Yeah? Making sense? Everybody with me? So net, we did not do anything fancy today, okay? It might have looked little overwhelming, and I was kind of thinking whether I should explain this or not, or whether we should try deriving this or not. But then, again, as I said, I have done all this 25 years ago, maybe 30 years ago. So, I did not remember the formula. Amuga told me a formula because she knows about it. I did not know it. I said, okay, let's try finding it out. We found it out. That is how mathematics works. That is how math works. You have to find out the formula, you have to find out, you have to question yourself why and how. More you do it, more you'll be able to get into the root of it and you'll become conceptually much stronger. Yes.
Whenever you do like a logical question, you actually find like
No discussion, please. That's not needed right now. Okay? We'll come to that. So what I'm saying is, if you come across any problem like this, think about it. Break it down
trend.
and then try. So here, we have to find out the area of a trapezium. What did we know? Okay, these two lines are parallel. I know this is my A and this is my B. And the height between them is h. That's the only thing we knew. We said, okay, fine, this is the height. Let's draw a perpendicular line so that I can break this into three components. This is my right angle triangle, this is my rectangle, and this is my right angle triangle. We know the area of a right angle triangle, we know the area of a rectangle, we know how to find out the area of this right angle triangle also. Found out the area, added them together, and then we found that okay, this has this and this common. Add them together, that becomes this side, that is B, and then this is parallel to this one. So basically, once you had the area in place, when you broke it down, you were able to add them together, and that is what gave you the area of a trapezium as half into height into sum of the parallel lines. And as I say always, I'll say it one more time, I don't trust you. Only during the class. Meaning, I don't trust anybody when it comes to maths. Amoga said this is a formula. I said I don't trust you. Let me find it out. And I'm not saying that I don't trust my students. I trust each one of you. What I'm trying to convey here is, don't take any math on its face value. Always solve it by yourself. Don't trust anybody. If they say, okay, wait. If somebody says, this is the answer for this. Oh yeah, okay, fine. Don't do it that way. Solve it by yourself, then you will be able to confirm whether your understanding is right or not. And that is what I mean by conveying this message to you guys, that I don't trust you. Meaning, I don't want you guys to trust anybody when it comes to math. Solve it yourself, and then only you will know whether whatever is been told to you as an answer is right or not. Okay, yep, you have a question. Again, that's not a debate. Again, as I said, don't trust your dad also. You will only solve the problem that you learn by yourself. Because in the examination hall, neither your teacher will be there nor your dad will be there. It will be only you. Neither your own brother will be there. So, what I'm trying to say is, that is how you build yourself when it comes to knowing math or learning math. Somebody say, okay, fine. Find out the area of this trapezium. This is a formula. Okay, if you know the formula, apply it and solve it. And then validate. I have seen enough instances in my life when the answer sheet itself has wrong answer. And don't be surprised if you come across that, okay? There have been times when some kid goes for a given exam, and in the examination hall, when they validate the answer sheet itself is wrong. The 4 choices that you are given, your answer is not matching with any of them because there was a printing mistake. It's possible, right? It's a human error. So that's why I'm saying, solve it yourself and then you can say whether this is right or not. Don't trust anybody, don't rely on anybody, no matter how respectable that person, how close that friend is. Okay? So, when I'm saying I don't trust you guys, don't get me wrong. I trust each one of you as somebody whom I will lean on to get a perfect SAT score, okay? That is why we are studying in the class. SAT score, that's the score that you need for your college admission, okay?
What is it 100%? Do you get the IQ?
you get, I'm only teaching math, okay? If you get 100% math, which is your scoring subject, we'll see where you land, okay? Let's not worry about the result, just do your work, okay? So, I mean, huh? Wherever you will go, okay? I know you guys you all will have a very good future, let's not worry about it. Let's focus on learning math so that you get a perfect score. Once you get a perfect score, then you will decide where you want to go. If you want to go to Collin County or you want to go Ivy League, that's up to you. Okay, stop it there. So, any questions with respect to what we have learned so far? Now, so we also learned how to find out the area of a trapezium, which I was a little reluctant about. Okay, I was thinking that probably we'll do it later. But good that, no, it's not difficult, right? We could do it. We learned how to find out the area of rectangle, square, trapezium, rhombus, kite. What else do you need? We are done with quadrilaterals. Okay? And we have all proved it by ourselves. We are not relying on anybody. We are not relying on a notebook which says this is the area, remember this. Now, let's solve two problems quickly just to ascertain that what we have learned, we have actually digested also. Let's find out area of now I have to give a name, okay? This is kite, right? Because my drawing skills are not great. This is rhombus. Okay? And this is trapezium. The two parallel lines are 5 centimeter, 12 centimeter, and the area is equal to careful. Area 85 centimeters square. I want you guys to find out the perpendicular distance between the two parallel lines. And you guys have to pay attention to what I'm saying. I said, this is a trapezium where my parallel lines are 12 centimeter and 5 centimeters respectively. And my total area is 85 centimeters square. Find out the perpendicular distance between them. This is the one, yeah, whatever you call it. Now, second question is that I have a rhombus and a kite. Both have the same area. Both have the same area, okay? As 500 centimeters square. Okay? Area for both the rhombus and the kite is 500 centimeters square. One of the diagonals of the kite is 50 centimeters. Find out the length of the second diagonal. Okay? I'm saying it's for the kite. And this guy also has same 550 centimeters square. One of the don't murmuring in between, okay? One of the rhombus is 30 centimeters. Find out the second diagonal. So, what I'm saying is, I have a rhombus and a kite of the same area, 500 centimeters square. The diagonal, one of the diagonals for the rhombus is 30 centimeters. Find out the second diagonal. For the kite, one of the diagonals is 50 centimeters. Find out the second diagonal. And the second question is, I have a trapezium whose area is 85 centimeters square. One of the parallel side is 5 centimeters, second side is 12 centimeters. Find out the height. Yes, who will raise his hand? Dikshita. Yes, and Vivan.
So what is the centimeters up there? I can't see because the light is like...
Which one?
The kite one.
The kite, the area is 500 centimeters square.
Oh, okay.
one of the diagonal is 550 centimeters. We have to find out what is the second diagonal.
Okay, sir.
For rhombus, the area is same 500 centimeters square. One of the diagonal is 30 centimeters. Find out the second diagonal. Yep. No calculator till 9th grade.
What do you mean? Wait, so
I'm talking English.
so that means
No calculator till 9th grade. I will not allow in the classroom.
so that means that we can cheat in ninth grade?
Did I say so? I said no calculator till 9th grade.
Yes.
What that means is, I will make you guys practice with your own calculation till 9th grade, at least in the classroom. Now
Why do you need calculator in ninth grade?
Wait till 9th grade.
This is
There are things that you learn in 9th grade.
BC already. This is what.
Yep.
For the rhombus, it goes for intervals.
It will not. It will not. So do your calculation first. You guys are focusing a lot on talking. Do the solution, do the math first. No, don't do that. So once you guys are ready, raise your hand. And do the calculation quickly, okay? Yeah, you are ready?
Yeah, for the rhombus is 10, the height is
Rhombus, the height is 10. It cannot be.
10. Yes?
Sir,
It cannot be.
the,
Don't rush, do it calculation. Yep. Yeah,
the
mix it up.
kite is 10
Kite is 10.
centimeters square.
Mine is 10.
Why? Why 10?
It is 10. That is
It will not be 10. That's what I'm saying. What was the area for a kite? D1 into D2 by 2.
all right.
Where did by 2 go?
What's the area of the kite?
So it goes at 25.
I'm sorry?
20.
What's the area of the kite?
Area of the kite is also 500 centimeters square.
Oh, okay, I couldn't see it.
I'm sorry?
I couldn't see it.
Yeah.
Is it 20? The kites?
No guesswork. We can do it.
20.
It will be 20. Yeah. Calm down. Calm down. I said calm down. Class is something you have to be very, very, what do you call it? Organized, disciplined. You cannot do things that I will not allow.
It's too hard.
Yep.
The rhombus will go for intervals.
It will not. Simple calculation. Tell me, you cannot keep on arguing, right? Area of a rhombus is what? D1 into D2 by 2. What is D1 here? 30. What is D2? I don't know.
Yeah, I do
By 2 equals 500. How will it go to infinity? Tell me.
That's impossible.
How will it go to infinity? Tell me. It's simple math. Yep, Myra.
For the second diagonal for the kite, I got 2.5 centimeters.
For the kite, 2.5.
Yeah.
No. What was the area you had considered? Area is 500 centimeters square.
Yeah.
One of the diagonal is 50 centimeters. Second diagonal is not known. What is the area for kite?
500.
I'm sorry?
The area of the kite is 500 centimeters.
No, I'm saying formula. Formula for area for kite is D1 into D2 divided by 2.
Will the rhombus
What is D1?
I got it.
What is D1? 50. What we don't know is D2. By 2 is this. Area we know is 500 centimeters square. So 50 into D2 divided by 2 equals to 500. So D2 will be 500 divided by 50 multiplied by 2. So that makes it 20. Yeah, Bhuvan.
I'm gonna say
20,
20.
yeah.
Yeah.
Is it 8?
I have given the answer right in front of you. 30 into d2 divided by 2 equals to 500.
What?
So d2 will be equal to 500 divided by 30 multiplied by 2. Yep.
Is there a trapezoid answer 10?
I will come to that. Okay.
Yeah,
So
32.
32. How come? 50 into 2 is 100 divided by 3. That gives you 33.3333 and so on. It's not going to be 32. See, again, I would say it's always important to be quick, but quick with accuracy. That's where it matters. Don't just be quick with mistakes. 100 by 3 is 33.33. I'm sorry? So 100 by 3, you can stop at 100 by 3, that should be enough. Now trapezoid. What we know is area is 85. Area of a trapezoid is half into height into sum of the parallel sides. Height is what we don't know. Sum of the parallel sides is 5 plus 12. So this is 85 equals half into height into 17. So height equals 85 into 2 divided by 17. So 85 is 17, 5 by 85 into 2. We can do tic-tac-toe. This and this is gone. 10.
She told you it was 10. She actually did it. I told you you said no.
When did I say
You said no.
no? No, so you said 10 for this guy. That's why I said.
I said no.
Okay, don't argue with me. Don't argue with me. I have not come to trapezoid. So that's why I was talking about kite and rhombus. Don't waste your and my time arguing unnecessarily, okay? Alright. So everybody is clear with what we have done so far?
Yeah. I think I was wrong this one.
And what is that?
I'm wrong this.
Okay.
21.32.
31.32. Okay, so it was 31.32. How come? No, d1 into d2 divided by 2 is the area. Now d1 is 30, d2 we don't know, divide by 2 equals 500. So d2 will be equal to 500 into 2 by 30. That is what was giving me 100 by 3. How come it will be 21 point something? So, okay. Now the point here is, anything that we do with any sum, right? Once you found the formula, you have to just substitute the value and do the calculation with a peace of mind. Don't rush. Don't hurry up because you have to do it first and then you have to raise hand. No. There is no value for being fast and being wrong. There is more value for being late and being accurate. Late and accurate, right? Rhyming words. It's okay to be late but accurate. Okay? So don't rush, because in the examination hall also same thing will happen. Let's say you have 10 questions to solve.
Oh, I got it. 33.32.
Yeah. Yeah, Myra.
Can you read the question again?
Which question we are talking about?
The trapezium question.
The trapezium is, this trapezium has two parallel lines of length 5 and 12, and we don't know the height or the distance between the parallel lines. What we know is the area. Area is 85 centimeters square. Okay? So we have to find out the height or the perpendicular distance between the parallel lines. Okay? So yeah, coming back to what I was saying was, if you are in an exam, you have 10 questions to solve. You are rushing for everything. You are able to finish all the 10 questions 15 minutes before the exam gets over. 7 of the questions go wrong. How much did you get? 30%. You are taking your sweet time. You are not able to go very fast. You are able to solve only 8 questions. But you were accurate with those 8 questions. What did you get? 80%. So now you look at 80% versus 30%. Even if you say 15 minutes, you came out of the classroom early, you had time to have a soft drink after the exam, but then result will say something bad. So that's why I'm saying, if I appreciate or I expect you guys to be quick, I would tell you all the tricks to be quick, but not at the cost of accuracy. That would be our focus. Okay? So always focus on being accurate. Make sure that you're spending time to review what you have solved, and then when you will only be confident when you have reviewed and you don't find a chance of being wrong. Okay? Yeah? Yeah? Everybody with me so far? Okay. Then that's all we had. So yesterday we learned about how to find out the area of a rhombus. Today we learned two things: how to find out the area of a kite and area of a trapezoid. That brings us to the end of the class. And in the next class, we have done enough of geometry. Okay, let's change to something else. Algebra.
Ancient Greece.
I'm sorry.
Ancient Greece.
What is that?
What about Fibonacci series?
Algebra. I'm not wasting time talking about bubble shot, Fibonacci series, or things like ChatGPT.